Good afternoon, everyone, and welcome to today's lecture. This is friction, and we are dealing with friction. We are in the process of understanding friction, and I guess today is Thursday. We should be able to finish it by the end of this week. That is what I am planning to do. In the previous class, we had seen that friction is just another force. It's a form. It's coming from the contact between the two bodies. It is parallel, and the only thing it does is that it opposes the relative motion. And we had seen what happens with friction. We just have to apply a frictional force Fk, which is equal to mu k into n, and the rest of the question remains exactly similar. Okay, mic is not working, doesn't matter. I am working, my voice is reaching you, I can see you, that is more than enough that we require. Everyone is there, right? Everyone can see me, everyone can hear me, everyone can see what I'm writing on the board. That is more than enough for me to continue with this class. We had also seen if you place a block on a inclined plane, what is the acceleration of this block. We will come back to this block, don't worry. Someone told me that the block will not move. We will also see when the block is going to move and when the block is not going to move. Don't worry about that, we will come back. Let us now concentrate on what happens in your normal question when friction comes. And I must tell you that nothing extravagant happens. The question remains same. Nothing changes in the question. The only thing that changes in the question is that we have to just take friction into account. And how are we going to take friction into account? Let us do this question, and then you will realize that every question we have done till now, we could have done that question taking friction into the picture. What would have changed? So I think we have done many questions of this type. This is the simplest of the lot, right? We started Newton laws of motion with questions like this. We are supposed to find out the acceleration of this block. The only thing was, up till now, the block was kept on a smooth incline, a smooth surface. The only thing that has changed here in this question is the value of mu k. The surface now becomes rough, and the value of mu k is, let us say, 0.3. The value of mu k is 0.3. We are not going to do much questions on this because we have already done questions on this and we know how to do them. We have done questions where they were not attached with a single string, they were attached with multiple strings. We have done all sorts of permutations and combinations. This is just to tell you what is different when friction comes into the picture. So this is the question. Again, you have to do the same thing, one and the same thing. You have to find out what is the acceleration of these blocks. Remember this. First of all, tell me, where is this system going to move? I mean, in terms of the block, is the 5 kg block going to move down, or is the 5 kg block going to move up? Down or up? That decides where this system is going to go. Where is it going to move? Up, yes or no? We're going to move upwards. Everyone understands this, yes or no? Everyone thinks that this, everyone knows, not thinks, everyone knows that this block is going to move upwards. Can anyone give me a reason why it is going to move upwards? There must be a reason that makes you think that the block is going to move upwards. Can anyone?
Sir, it is a smooth pulley.
Yes, beta?
It is a smooth pulley.
So what has smooth pulley got to do with the block moving upwards or downwards? I don't understand it. Don't understand the logic. What has the smooth pulley was also always smooth. What has smooth pulley got to do with which side the block is moving? It has got nothing to do with which side the block is moving. Whether the block moves this side or this side, pulley always remains smooth. So can anyone give me more convincing reason why you think that the block is going to move upwards? I mean, one class.
Yes? Sir, 5 kg block is less than 10 kg block, sir. So it will move, sir. 5 kg is
5
less
kg
than.
block is less than the 10 kg block. So the system is going to move upwards. Very handsome and very smart answer. I must say it's a very handsome and a very smart answer. I mean, that is really great that you have thought it up till that level that, one block is 5 kg and the other block is 10 kg. So the system has to move on the other side. Well done. That is really great. I did not think that you will think it that way. I was not prepared. So you have actually surprised me. So let me take you. Oh, that's the reason. Okay. So as we can all see that mm, this 5 kg block is going to move upwards, and I fully understand your reason because 10 kg block is heavier. The 5 kg block is going to move upwards. So can you tell me the acceleration of this block? The 5 kg block is going to move upwards. I understand this, and I have no um, reason to disregard your opinion. So this block is going to move here. So this block is going to move here. Well done. Well thought. Nice logic. Can you tell me the acceleration of the blocks? You have 2 minutes to do it.
Sir, 30 newtons friction.
Yes, bacha. Yes, bacha. Anyone said something? I could not hear it. So probably sometimes my ears ring. They hear things which they cannot hear. Just now, I mean, 1 hour before I was trying to lay down and relax, I could hear sounds were coming from, I don't know, from some other dimension or maybe some parallel universe. I could not see anything, but I could hear a lot of things. So my ear rings. I mean, there is no specs that come for ear. My eyes went bad, so I put on specs. Probably would have to put a hearing machine because my ears ring. So no one said nothing. We keep on finding out the acceleration. It is such a difficult question that I still did not get any answer. Is that? Trust me, we have done a question which were 50,000 times more tough than this one. This is 50,000 times less tougher than the other question that we have done. 50,000 times. Yes, anyone with an answer?
Minus 4/3.
Minus 4/3. Minus 4/3. Oh. Did you ever get acceleration minus anywhere till now? Minus 4/3. Okay. Chalo. Minus 4/3. How did you get minus 4/3? Let's start our conversation from here. Minus 4/3. And how did we get minus 4/3? So, okay, let me draw the free body diagram for all of you. This is how much? 50 kgs? Sorry, 50 newtons. Everyone understands this? Yes or no? Remember, the block is moving up. Tension is T. Well done. This tension is T. This is 100 newtons. Okay. This normal reaction is N. this block is not going to go jig, 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 jig like this. So your normal reaction becomes how much? Normal reaction becomes how much?
100 Newtons.
100 Newtons. Well done. Okay. Now I have to think about friction. Friction is going to be kinetic in this case. Where is the block moving?
Left side.
Left side. So friction has to be on the
Right side. Tension and force.
The friction has to be on the right side. Well done. Friction is on the left side. Very good. Tension, friction is on the right side. Tension is on the right side. The block is moving left. Kamal hai. The weight is acting downwards. Nothing is acting on this side, but still my block is moving up. That is magic. Pure magic. It has got nothing to do with science. Because this cannot happen in this universe. That all the forces are on one side, but the block is moving on the other side. This is not possible in this universe, my dear friends. Not in this universe. Because in this universe, Newton was there and he gave us Newton laws. And he told us that wherever there is force, if there is no motion before, everything only moves in the direction of force. But here, in this non-Newtonian world, we have all the forces on one side, but the block says, no, I'll move on the other side. That is not going to happen. So your logic is flawed. I mean, there is no logic at all. This is utter nonsense that you have told me, that the block is going to move. Who is going to pull the block upside? God? I have heard about the hand of God in one of the very famous goal, which was scored by the Sir Diego Maradona, when God's hand came and ball went inside the goal. There was also one incident 2 days before where CR number 7, my son calls him CR number 7, Cristiano Ronaldo number 7, he's got the hair of God and the ball went inside. But here there is no hand of God and there is no hair of God. The only way the system can move is downwards, because there is nothing pulling it upwards. Just because I put a 10 kg block, it's not going to pull it that side, because it's not, gravity is not working for it. It's kept on a horizontal surface. God is not going to pull it there. So let's not believe in God. Let's believe in Newton. And let's now do the problem correctly. There's no way this block can move there. There's no force which is moving it there. The only way this block can move is downwards. This is the acceleration A, and this is the acceleration A. Since both the strings are connected to each other by one string, both move together with the same acceleration. Do we understand this, or this has gone above our saying bye-bye? Or we still believe that other universe theory, where I hear noises coming from other universe and you see block moving upwards? It does not happen in this universe. This universe, block will move downwards. So let's remain in this universe. It is a very good universe, only 4% of which we see, but it is amazing. Trust me. So now can you give me the answer for acceleration of this after so much of theatrics that I have put? That is the meaning of theatrics. When this hero comes, he comes with all sort of phata pushta nikla hero and all those things. Theatrics. They call it theatrics. And that's why I like Batman. He always comes with all sort of funky music playing, and everyone is in dark, and then Batman appears and he kills up those goons. I love Batman. There's no Batman here also, but can you solve the question without the theatrics, applying pure Newtonian physics? Yes, what is the answer? So now acceleration is downwards, so the friction would be acting in the backward direction. Now our logic will come, sir, friction is backward, so it can pull it up. No, friction is backwards because the block is moving forward. So don't use that logic, beta. That logic does not make sense. So your kinetic friction is on the back side, How much is the value of this kinetic friction?
30 newtons.
30 newtons. 10 is 100 is n and nu k, so it is 30 newtons. Now you don't have to write the equations because now we have done this question 10 and 10,000 times. One force which is trying to pull it from here is 50 newtons. The force which is trying to stop it is 30 newtons. So what is the acceleration of the blocks? You don't have to go any further than this, right? What is the acceleration of the blocks?
4 by 3.
Huh? I can't hear it, but I hope you have understood. So that would be 50 this side minus 30 that side divided by the total block 15. So it will be 20 by 15. And you see, no negative comes here. It becomes 4 by 3 meter per second square in the downward direction. Do we understand this? So the only difference this kinetic friction makes is that you just have an additional force which opposes the motion. And it is something like pseudo force. But remember, this is a real force, not an unreal force. I'll give you 1 minute to note it down. Do it fast. Everyone understands this? Yes or no? Okay. So any question that comes on friction is a simple question where you don't have to do anything extra. Just see where the system is moving. Just apply frictional force in the opposite direction and we are done. Okay, I will not go into more problems on friction because they are just a repetition of what we have already done. Do we understand this? Problems remain same, only friction gets added, nothing else. Okay, let us go back to that inclined plane wala problem. This inclined plane problem. Now, you know that when this body is moving down, the acceleration we had found out was g times sine theta minus mu k cos theta. Do we remember this, everyone? Remember this because this is going to come many times. Many times it is going to come when the body will roll also, then this will also come, and you will see the difference between what is happening here and what is happening there. So remember this. Someone told me that the body will remain at rest. Someone told me that the body, and where is my body? This is my body. Someone told me that this body will remain at rest. Where is my inclined plane? This is my inclined plane. So my inclined plane right now is horizontal, and I keep this magical body. Remember, it will follow Newton's law. It will not move on this side. You say, sir, it will move this side. Huh? It will follow Newton's law. It will just come down. Now see, when this body is kept on this horizontal thing, nothing is happening. It does not move. No God's hand here or no God's hair. Now when I start to increase, see, the angle has increased, but it still does not move. Someone said that it will not move. See, now I'm slowly increasing the angle, still not moving. At one particular angle, it just moves. At one particular angle, it moves. See, again. That angle is known as the angle of repose. It's the angle of the inclination at which the body kept on top of it starts to move. That is known as your angle of repose. Do we understand this? Angle of repose. And I think you have a practical based on this in your 11th standard, in which you will have an inclined plane whose angle can be changed, and you have to find out the value of this angle of repose. How are you going to find out the value of this angle of repose? In the exact same way in which I conducted this experiment, you will have this inclined plane and you will slowly start increasing what? You will slowly start increasing the angle of that inclination, and at one point it will start to move downwards. At one point it will start to move downwards. This is the block which is kept on top of it. What? This is the block which is kept on the top of it. At one particular angle, this block will start to move down. Angle of repose is the angle at which the block starts to move down. Angle of repose is the angle at which the block starts to move down. Now, why does it start to move down? Now, if we try to analyze this, if I just draw the free body diagram, remember this is a rough surface. If it was not a rough surface, the block, as soon as you just make a angle 0.01 degree, it will just fall down. This block is not rook, it is rough. Why I am writing rook? This block is rough. Now, if you analyze this, if I draw the free body diagram of this gentleman, this weight mg always act downwards. This mg cos theta, mg sin theta, sorry, will always try to pull it down. This mg cos theta will be here, perpendicular. And then we have also our perpendicular friend normal reaction. And then jig did not happen. So this n will be equal to mg cos theta. Now, what happens when you are increasing the angle of inclination? Since you are math student, you understand this. The value of this sine theta, since theta increases, the value of sine theta increases. Yes or no? From 0 to 90, the value of sine theta increases, but the value of your cos theta decreases. Cos theta decreases, sine theta increases. Now, the sine mg sine theta is trying to pull it down, but someone is trying to stop it. And who is that gentleman who is doing this stopping work? This gentleman is our new friend or old friend, the friction. Now remember, this friction cannot pull it up, huh? It has to move down. There is no God's hand here that is going to pull. So friction is upwards, so it will move upwards. So it's not going to move upwards, it has to move downwards. Now this friction is trying to stop it. And the value of this friction can be written as mu into n. Now, when this downward pulling force becomes equal to that upward pulling force, because this is increasing and this is decreasing, this block will start to move down. Yes or no? Because no one can stop it now. This force, the pulling force, has become more than the force which was stopping it. In that case, what will happen? The block will start to move down. So for the condition of block to move down, will be this downward force will be equal to upward force. If I write this downward force equal to upward force while equation, you will get mg sine theta will be equal to the mu k. You can write it as mu k into cos theta multiplied by mg. This mg goes away, and you get the very famous result that tan theta of this angle of repose is nothing but equal to your mu k. And this theta was again this mu k was again equal to your angle of repose. This is now angle of repose. Let me call it as theta r. Now remember, this mu k was also equal to your angle of friction, tan theta of angle of friction. So basically, angle of repose and angle of friction become same. Do we understand this? Angle of friction and angle of repose actually become same, and tan theta of that becomes equal to mu k. So at this particular angle, this block will start to slide. If your angle of inclination is more than, if your angle of inclination is more than angle of repose, no one can stop the block from sliding down. Do you understand this? Yes or no? You understand this? So, what is the condition for block to slide down? What is the condition for block to slide down? If your angle of inclination theta is greater than, or if your angle of inclination is greater than, or let us say equal to your angle of repose, the block will slide down. The block will slide down. Do you understand this? What happens if your angle of inclination is less than the angle of repose? Interesting case. What happens if your angle of inclination is less than the angle of repose? Yes, what will happen then?
Will be at rest.
The block remains at rest. Block remains at rest. Now, block remains at rest. That brings us to the next question. Is there any frictional force acting on the block still? Is there any frictional force acting on the block still? Or no?
Yes, sir.
What type of frictional force is acting on the block now? When the block remains at rest?
Static friction.
Comes our new friend, static friction. Friction still acts on the block, but it is now known as static friction. And this is the grand entry of our new friend, static friction. Static friction comes into the picture now. Dun, dun, dun. And it's a very theatrical entry by static friction. It comes with the inclined plane. I could have made a more less theatric entry with just putting it on the horizontal surface, but I wanted a entry like a hero. That's why inclined plane and this going there and this going there, and static friction appearing from nowhere. Static friction denoted by the legendary letter F, small f, with S denoting it is static in nature. Now let us understand what is static friction. Now again, this is coming from the contact force. This is the parallel component of contact force. We can't change it. It is like this. So the first point that you will remember about this is the parallel component of what? Parallel component of your contact forces. Whenever two bodies are in contact, they exert forces on each other, contact forces. Because of this contact force, you can have one normal reaction force and one parallel component. What is the what and when the static friction comes? The static friction Fs comes when there is no Rm. What do you mean by Rm?
Relative motion.
There is no relative motion, but there is something else. What is that something else? There is no relative motion, but there is a tendency of relative motion. Do we understand this? So we don't have a relative motion, but there is a tendency of relative motion. But there is a tendency of relative motion. There is a possibility of a relative motion. Relative motion can happen Even though it is not there, there is a possibility of it happening. Now remember, friction is a force, and whenever we talk about force or any vector, there are two things that we must be considered. There are two things that we must think about. What is that? What are the two things? What is the first thing? Huh? Whenever we talk about any force, any vector, we must be considered magnitude and direction. I first consider direction because in vector, direction is more important. The direction of static friction. Direction of static friction would be such that it opposes what? It opposes the tendency of relative motion. The direction of static friction would be such that it will oppose the tendency of relative motion. It understands that there is no relative motion, but it also understands that this gentleman is trying to move. You know that this is trying to move. This is acting smart. This body is acting smart. It wants to move. I will not allow it to move. Therefore, I call this static friction as smart friction. I call it smart friction. Why I call it smart? Because it is smart, and we will see smart friction, and we will see the smartness as we go along. This is a smart friction. Because even if the body is not moving, there is a feeling inside this body that I want to move, and the static friction understands that feeling. Oh, okay, you want to move? I will not allow you to move. Kinetic friction is just simple. When something moves, okay, you are moving now. Okay, let me be in the opposite direction. But this static friction understands the feeling of the body. Okay, you want to move. I'll stop you. Smart friction. Now, how do you find out the direction of the static friction? You just have to find out in which direction the body wants to move. In which direction the body wants to move, and you just apply this static friction in the opposite direction. Let us take the example of that inclined plane problem. The body is kept on an inclined plane. Ding, 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 ding. Mass m. Remember, this is rough, but the body remains at rest. The body remains at rest, but it wants to move. Where does this body want to move? Huh? Where does this body want to move? This body wants to go downwards. So the static smart friction, and okay, you want to move downward. Right? Wait. So the direction, so it applies the friction in the backward direction. All hail the smart friction, the static friction. Static friction is backwards. Smart friction. He understands where he wants to move, where this body wants to move. Smart friction. See? Let us take one more example of his smartness. There's a body of mass m, heavy body, just like me. It is rough. Yeah. Surface has to be rough, otherwise static friction will not come. Smart friction, you see, you will see the smartness. It is more smart than me and you. Now apply a force of 10 Newton onto this. Apply a force of 10 Newton onto it. This body is not moving, it is at rest. But the smart friction understands that this body wants to move. You want to move. What is the direction of static friction?
Right side. Right side.
We should be smart enough that static friction, without being a living thing, can understand where the body wants to move. So we, being living beings, Must be able to understand where the body is going to move. Body is going to move right. So the static friction, being as smart, created smart creature, she knows or he knows, whatever, that it has to be backwards. So static friction is backwards. See, no motion, but it understands. It understands the feeling of body where it wants to move. Second case scenario. I said, okay, static friction, you are acting smart. Let me be more smart. So what do I do now? I want to make this static friction get confused. How will you know? Now I start to apply this 10 Newton force on the reverse side. The body still remains at rest. I want to confuse static friction. But now static friction again understands. What is the direction of static friction now?
Left side.
Left side. See, static friction, I told you, is smarter than us. We know that the body wants to move left. We can't see that the body wants to move left. So this static friction now quickly, see, it is smarter than us. Quickly changes direction and it comes on the left side. See, smartness. We don't understand where this body wants to move. Static friction knows it. So let's be at least as smart as static friction. If you're as smart as static friction, we will understand static friction. So now static friction just changes its direction and say, okay, I will now go on right. See, you can't move still. You can't fool me. We could not fool him or she or her, whatever. Static friction is smart. It keeps on changing its direction. It understands the feeling of the body. Kinetic friction is simple. Hey, you are moving now, okay, right, you are moving, okay, I'll be on the left, don't worry. I'm simple man. But there's a static friction is the smarter brother. And there are two twin brothers, static and kinetic. Kinetic is, you must have seen Hindi movies. One of the twins is always like Sida Sada, simple boy. So kinetic friction is simple boy, but the static is the one who is that Coolie number one came. Purana Coolie number one and new Coolie one. It had two Govindas. It had two David Dhawan ka sons. One was just normal. The other one was a smarter one. So the static friction is the smarter one here. Now let us talk about the magnitude of this gentleman. Kinetic friction is simple, straight, just like me, simple and straight. Mu k into n. Man. What about the magnitude of this static friction? Magnitude of static friction. Now remember, this is a smart friction. It can change its direction, we have seen. It can also change its magnitude. The magnitude of static friction is not constant. What the hell? It can vary. It can vary from 0 to a maximum value. Now the things are getting more interesting, you see. Smart friction we are dealing with. The maximum value of static friction, is known as, anyone, any idea? Limiting friction. Limiting friction, and it is represented by FL. Limiting friction is the maximum value of static friction. So he's smart, but you know, every seer has a sawa seer, so he can only be smart till a particular level. Smartness is up to a particular level. That level is your limiting friction. It limits it. Poor boy. It has been limited by the limiting friction. And the value of this limiting friction is fixed. So we can't change that limiting friction also. So there comes the sad part of the story. The value of FL can be written as mu L into L, mu L into N, or not writing mu L because it is not written in the form of mu L. It is written in the form of mu S into N. Don't get confused. Mu S into N. And this mu S is known as, it is the brother of mu K. And this mu S is known as coefficient of static friction. And it only depends on the two surfaces in contact. So it is a brother, both are brothers. So if you want to change the value of this mu S, you have to change the surfaces in contact. In short, if I say the smart friction, S for static, S for smart. The static friction, the value of this static friction, if I write it mathematically, 0 is less than or equal to Fs, is less than or equal to Fl, and this Fl, remember, this Fl is equal to, this Fl is equal to mu s into n. I can't change it. Now we have seen the smartness of static friction in terms of direction. It understands the feeling of the body, where the body wants to move, and adjusts its direction accordingly. Let us see how does it change the magnitude. Let us go back to our. Everybody noted this down then? Yes or no? Let us go back to our problem where we saw the smartness of static friction. And let us call this problem as problem number A. Now in problem number A, what is the value of static friction? And it should not take rocket science for us to understand it. Static friction is smart. We have to be as smart as static friction. As for static, as for smart.
US into MG.
Static friction is smarter than us. Take a deep breath. Open your eyes. Look at the diagram and see what we have been doing for the past 1 month. Just do that and tell me the value of Fs. Should not take rocket science. Open your eyes. Open. Anyone? What is the value of Fs? Remember, the block remains. Yes, what is the answer of Fs? What is the value of Fs? The value of Fs has to be 10 newtons, my dear friends. Then only it will remain at rest. If it is less than 10 newton, it will move. If it is more than 10 newton, God's hand will come and it will move on that side. I will apply force on you and it will move here. So God's hand is not going to come, because the static friction is bound by Newtonian laws. It follows. It knows, even if it does not know the name of Newton, it follows Newton laws. We know the name of Newton. We have seen the photo of Newton. We have understood. We have done the we have read the laws of Newton, but we still don't understand Newton laws. This is non-living thing. It understand Newton laws. It understand that 10 Newton is there, so I must be 10 Newton here. 10 newtons is your value of static friction. Smart friction. Does not understand Newton law, but he's smart. Let us go to case number P. Same question now comes now. It has changed its magnitude. It has changed its direction. We know smart friction, static friction. What is the magnitude of static friction? He does not know Newton.
10 newtons.
Now we knowing Newton have becoming smarter. See, we need Newton to become smart as static friction. He, without knowing Newton, becoming smart. The value of static friction is 10 Newton. Well done. Let me change the question. I feel, oh, static friction, trying to act smart. I will check your smartness. You smart people making fool of me. I know Newton. I know Newton law. What do you know? Nothing. You are just static friction, a non-living being, taking panga with me. So I increase the force. Hey, now see Newton. Now see static. Newton, tell me, what are you going to do now? The block still does not move. The block is very heavy and the friction is very high. The block does not move. The block still remains at rest. I know Newton law. I know everything. Static friction does not know anything. What is the value of static friction now and the direction of static friction now?
If you consider left side,
Same block, same everything. I have increased the force to somehow fool static friction. Static friction does not get fooled. Hey, I am smarter than you. I may not know Newton, but I know I have 215 Newton now. So the value of static friction here is 15 Newton. Smart friction. It can change its direction. It changes direction in the previous case. It can change its magnitude also. Hey. See? But the smartness has a limit. So if I keep on increasing the force, at some point the smartness will give away because it cannot go above a level. It cannot be greater than Newton. It cannot have a mind greater than Newton because then it will be called Newton and not static friction. So if I keep on increasing this force, let us say, and I give you this example, let us say at 20 Newtons. Let us say that this is, let me say 5 kg. Let us say at 20 Newtons, this block just starts to move. At 20 Newton, this block just starts to move. When this block just starts to move, then what happens, beta? This friction, which is static, which is smart, it has reached its maximum level. It cannot increase further. So in that case, it reaches its maximum value because it is starting to move, just starting to move. The word that we use is just starting to move. If the just starts to move, that means the friction, which is static, which is smart, has reached its maximum value. The direction is still in the backward direction, but it has reached its limiting value, FL. Now you can say the maximum frictional force that can be applied on this block will be equal to how much?
US
20 Newtons. If I increase the force more than 20 Newtons, friction cannot do anything. Because now we have gone above the level of the smartness of static friction. But being a non-living thing, it has given us a tough fight. They've given us a tough fight. Okay, I will fight till the last breath. The last breath that it has, what? Limiting friction. Now, as soon as you know that the maximum value is limiting friction, which is 20 Newtons, let me just take n out of it. Now, this 20 Newton must be equal to mu s multiplied by n. Do we understand this? Here the value of normal reaction, as you can see, this block cannot move jig, 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 jig. So the value of normal reaction is 50. From here, you can find out the value of mu s. Mu s for this particular system, how much is the value of mu s for this particular system? Is 20 divided by 50. Do we understand this? Or 2 divided by 5. So when it reaches its maximum value, then only you can use the value of mu s. When it is not reaching its maximum value, it is acting smart. If it is acting smart, it keeps on changing its value according to the force that you applied here. Whatever force you apply in one direction, the same force it applies in the other direction, if it can. If it cannot, well, then the static friction goes away, the smarter weather goes away, and the simpler one, Sida Sada one comes, and that is kinetic friction. Say, okay, and now I'm there. Don't worry. Simple value, mu k into n. Enjoy your life. Go Simran. You can enjoy your life. Now I am kinetic friction. Don't worry about static friction. He was smart. I'm simple one. So the Simran will go away. I mean, the block will keep on moving and the friction will remain constant. That's it. That's for today. The introduction of static friction with as much theatrics that I can put in. I hope you understand that whenever static friction comes, remember you don't know the value beforehand. You'll have to look at the thing. Okay, this is this is this. And then you have to get as smart as static friction is. Remember, it is a non-living thing. Does not know Newton law. We know Newton law, so we should be able to find out the value of static friction. That's it from my end for today. Take care. God bless all of you. Bye bye.